Okay, welcome back. In this chapter, we're going to be talking about multiple causation. Okay, let's explore what that phrase might mean. All right, previously in an earlier lecture, we talked about the basic building blocks for experimental design, which would be to have one independent variable with at least two levels. In this lecture, I'm going to talk about how we can double that basic building block, and then ultimately we can start to, grow logarithmically into more and more detail. So let's just start off with doubling the basic building block. So when we talk about adding more independent variables, we call that a factorial design. So when we double the basic building block, instead of having just one independent variable, we're going to have at least two. So the word factorial comes from the word factor, and factor is another word for an independent variable. When we have a factor that contributes to an outcome or causes an outcome, we're talking about an independent variable. So when we have more than one independent variable, we're going to have the power to investigate several factors all at one time in a single experiment. I've got a little diagram there on the left that we'll explore a little bit more deeply. But when we add an additional variable, it gives us way more information. And it's not, I call this doubling the basic building block because we're going from one independent variable to two. But the power that it gives us to explain things is actually more like going from one explanation in the case of a single independent variable to actually three potential explanations when we get into a factorial design that has two independent variables. And we'll talk about that more. So here's an example, the one that was on that last slide, blown up so now you can see it. This is something out of industrial and organizational psych. So what you see on the y-axis as our dependent variable is job performance. And what you see along the x-axis is the two conditions that were provided. Either the participants got low training, a low amount of training, a small amount of training, or they got a high training or a larger amount of training on whatever their job is. And then you see that there are subject variables as the other independent variables. So we've got people who are low in autonomy and people who are high in autonomy. That's technically a personality variable, a type of intrinsic motivation. Some people are lower on the need for autonomy and some people are higher in this study. Okay, and so what you can see is that when there is low training available, job performance is virtually identical for the people who are low autonomy and high autonomy. But when there's a lot of training available, you see that there is a difference between the low autonomy participants and the high autonomy participants. You actually see higher performance in the high autonomy, high training participants. It looks like, just using my eyes, I don't have the statistics from this study, but it looks with my eyes as if the job performance of the low autonomy people did improve with the high training relative to the low training. It looks like that line is a bit of a diagonal and it's higher. But absolutely the high autonomy participants benefited more from the high level of training that was offered. So let's think about what we're looking at here and what we're able to explain. We can look at the effect of just training if we wanted to. We could say low training produces poorer job performance than high training does. To be able to say that, we would look at the average score between the low and the high autonomy people there on the left, and we'd say, well, that average score is lower than the average score for the high training across the low autonomy and the high autonomy. We could say that people who are higher in autonomy probably did better overall than people who are lower in autonomy. And in this case, we would be averaging across the training techniques. And we'd be saying, well, the average score for low autonomy is lower than the average score for the high autonomy, if we average those two scores together. So we could look at each independent variable by itself, basically, is what I'm explaining, right? We could look at just the effect of training. we could look at just the effect of level of autonomy, and then we can look at this interaction. And when we look at this interaction, it becomes really super clear that high training produces better performance, but especially when a person is high in autonomy. And that's the kind of information that we get. So see how I described 3 different potential contributors to behavior: the training, the personality trait called autonomy, and then the interaction of the two. And that's really the power that we have in this kind of experimental design, where we use multiple factors in the design. Okay, now here's a crazy looking one. This is actually something out of Human Sexuality. And we see on the y-axis mean sexual aggression. Always remember, the word mean in this kind of situation means average. It doesn't mean like cruel. So average sexual aggression score. Along the x-axis, we can see the level that the person was placed in what's called the Confluence model risk level. So there's multiple levels. Some of them are not included in this x-axis because you see that they're numbered 1, 2, 3, 4, 6, 9. So obviously they left some of them out. So we've got their risk level as determined by some model that they used, their risk for behaving aggressively. So that's one of the independent variables, the Confluence model risk level. And then we have, again, a subject variable, something that the participants came to the study already in their groups. So in this case, it was pornography use. And so you see at the very bottom, it's never. The next highest is seldom. Then the next is somewhat frequently. And then the very top is very frequently uses pornography. And what you can see is that overall, the Confluence risk model, if we were to just sort of vertically combine scores, hopefully, I think you guys can see my little arrow when I do it. Vertically, if we were to average these scores for the very low risk category, we would see that the average score is something in the middle here compared to the average score for the low risk, compared to the next low. I don't know why 3 of them are labeled low risk. So we'd see this average score for these 4 numbers. The average score, these are practically on top of each other anyway. So what we would find is that there wouldn't be that much difference among these 4 groups at all. And then we would see, okay, the average score for these 4, that's a little higher up. And then we'd see the average score for these 4. Well, it would only be a little farther up if it was these 3, but thanks to this one group up here, it's going to pull the average up altogether. So we may find that the first 4 levels of very low risk, low risk, low risk, low risk are all virtually identical. We'll see a slightly higher score for moderate risk and probably a much higher score for the high risk. And so if we just look at Confluence model risk levels, we would be under the impression that a high risk person is more likely to behave aggressively than a person who scored moderate, or for sure people who scored into one of the low risk categories. But that might mislead us. So let's continue to look at the individual independent variables by themselves. Okay, so if we have we're under the impression that high risk individuals are more likely to behave aggressively. Now what we would do next is we would consider pornography usage as an independent variable by itself. So what that would mean is we would average all of these never scores. We'd average them all together and come out with some number that is fairly low. We would then average all the seldom use together, and we'd end up with a number that's probably a little bit higher than the never use. Then we would average together all the somewhat frequently, and again, come up with a number that's not that different from the previous ones. Then we would average these very frequently use, and we would come up with a number that's probably substantially higher than the other 3 groups. And we would get the impression that high use of pornography by itself is a good predictor of sexual aggression. So we might think, if we only had one of those variables, that just being in the high risk group means that you are significantly more likely to behave aggressively. If we might come to the conclusion that just using pornography very frequently makes you much more risky. But when we take both independent variables together, we can then see how they're interacting with each other. And what we're really seeing is that across the Confluence model, we see a little higher risk across the different kinds of pornography use, but really not that much until we get to the highest risk, very frequent use. That's really what's pulling the whole thing up to the right. Like there's a slight increase across the model risk levels, and maybe slightly higher rates among people who are somewhat frequent users of pornography, and maybe even along the lower levels of the Confluence risk model. The very frequently we're seeing, slight increase across the model. But absolutely, that very frequently uses pornography group is pulling the whole model up. And what we can now see is that group, if you are in the high risk category and use pornography very frequently, you're at the highest risk for behaving sexually aggressively. So this kind of design really allows us to pull apart each of the independent variables and then also look at the interaction between them. All right, so all right. Really, this kind of design is the lifeblood of experimental psychology. I've told you before that correlational research is the lifeblood of psychology, and that's true. But when we talk about experimental psychology, this is how we do it. This is the design that we tend to use. It allows us to examine the combination of those independent variables. It's much more like the real world, right? The real world doesn't have a single factor that causes an outcome, hardly ever. Instead, in the real world, we have multiple factors that can contribute to an outcome. In fact, I thought I'd stop and talk for a second about another philosophical concept, the issue of whether a factor is necessary for an outcome and sufficient for an outcome. So let's talk about that a little bit. Very few variables are both necessary to an outcome. Like, for example, the gene for Huntington's disease is all you need to, for sure, develop Huntington's disease. In fact, it only takes one gene. It's that necessary. You only need one gene for it, and it causes Huntington's disease. Now, you'll notice I had to pull something out of biology medicine to come up with something, because I couldn't think of a psychological example of something that this is all you need and you are guaranteed to get the outcome, right? Like it's necessary and sufficient. And the other issue is that the variable needs to be both necessary and sufficient. Well, the gene for Huntington's disease is necessary and it's sufficient. It's all you need. Nothing else needs to happen for a person to develop Huntington's disease. I thought I'd give us an example that's a little closer to psychology, which is the exposure to the flu virus plus a critical period in gestation I use that weird dashed arrow, might lead to schizophrenia, right? Because that's a good example of how, maybe exposure to the flu virus might be necessary for development of schizophrenia. Perhaps we aren't at that place yet with the research on it to know that for sure. But let's pretend that exposure to the flu virus is necessary. It's still not sufficient to cause schizophrenia. It has to be combined with something else, like the critical period in gestation, or potentially the other something else that it would have to be combined with is a genetic marker that has not yet been defined. The idea is, for most things in psychology, it's like schizophrenia, right? We don't know if there's a single factor that is both necessary and sufficient to cause schizophrenia. So far, what we have is lots of different factors that may be combined with something else may actually lead to the development of schizophrenia. The fact that it doesn't always makes us say it's not necessary or sufficient, right? So very few variables, and particularly in psychology, there are very few variables that are both necessary and sufficient to cause an outcome. And so that's why factorial designs are so helpful to us, because we can start putting in more factors to determine which ones seem to at least be necessary. We may not know if they're sufficient, but we can at least say they're necessary to the outcome. All right, let's take a little break here, and in the next segment, we'll come back and we'll explore the issue of how many independent variables should we be including.